Aging. Well, Maurice Chevalier did point out it's better than the alternative. Here we have Ken. Ken's of an age where he's beginning to think about retirement. And as he's thinking about retirement, he's wondering, how long am I going to live? And how well am I going to live during my retirement? Of course, Ken's really everyone. Aging matters to each of us individually. And as I think most people in this room are aware, aging matters increasingly, collectively to us as a society as more and more people live into old age. However, aging is actually a very complex process. It's a myriad of genetic, behavioral, and environmental factors that affect each of us and how we all age very differently. Studying aging, therefore, is really quite difficult. I have a unique way of looking at aging. What I do is look at how long people who are already dead lived and simultaneously look at the DNA of their children. Using that technique, I've been able to gather 1 million lifespans and begin to analyze the genetic effects therein. Before I started my work, only one region of the genome had been pinpointed as affecting how long we live. I realized that if I asked people, how long did your mother live, how long did your father live, and at the same time took their DNA, the person's DNA, I would be able to make precise inferences about how DNA can affect how long people live. Better still, that data had actually already been gathered. It had just not been analyzed in this way. So I was able to ask 24 research groups across the world to send me their data and collect 1 million lifespans to infer, in fact, 12 genomic regions now have been pinpointed by my work as to how long people live and its affected by DNA. Lachesis, the Greek fate, was supposed to cut our thread of life and determine how long we live. In fact, DNA doesn't work like that. It's not deterministic, but DNA is very much beginning to reveal the underlying mechanisms of aging, how long we live, and how well we age. Thank you.